Please like and subscribe my YouTube channel, Hamza Electronics. Let's start our video.
Hey there, tech enthusiasts! Welcome back to Hamza Electronics. Today, we're diving into an exciting topic, the Synchronization Management Unit for IEEE 1588 and Synchronous Ethernet. We'll be exploring the fascinating world of the 82P33813NLG and uncovering how it revolutionizes synchronization in the digital realm. So, buckle up for a deep dive into this cutting-edge technology that is shaping the future of connectivity.
Ever pondered over the task of configuring the Synchronization Management Unit, or SMU, for IEEE 1588 and Synchronous Ethernet using the 82P33813NLG chip? It might appear to be a daunting task, but it's not as complex as it may seem. So, where does one start? Well, the first step is to familiarize yourself with the 82P33813NLG chip. Get your hands on the datasheet, user manual, and programming guide. These documents are your roadmap, offering crucial insights into register configurations, features, and functionalities of the chip. Having done that, it's time to set up your development environment. This involves accessing the chip's programming interface, which could be SPI or I2C, and ensuring proper power and signal connections. It's like setting up the stage before the performance. With the stage set, you're ready to dive into the IEEE 1588 configuration. IEEE 1588, as you might know, is a precision time synchronization protocol. You need to configure registers related to IEEE 1588 within the SMU to enable accurate time synchronization across devices on the network. Think of it as setting the rules of the game, where you'll set parameters such as PTP message formats, clock accuracy, timestamping, and synchronization modes. Next, we move on to the Synchronous Ethernet configuration. The aim here is to distribute clock signals through the Ethernet network. Adjust settings for frequency synchronization, clock recovery mechanisms, and Ethernet-specific timing parameters to support synchronous Ethernet functionalities. Now, with all the settings in place, it's time to get hands-on with the chip's programming interface, be it SPI or I2C. Use it to access and modify specific registers according to the datasheet's guidelines. It's like tuning a musical instrument, getting it ready for the concert. You might also want to write scripts or code to automate register configurations for both IEEE 1588 and Synchronous Ethernet settings. But how do you know if your configuration is correct? That's where testing and validation come in. Simulate network conditions or connect to actual devices compliant with IEEE 1588 and Synchronous Ethernet to test the configured settings. It's like the dress rehearsal before the final show. During this process, it's crucial to document your configuration settings, register values, and any issues faced. This will serve as a reference for any future troubleshooting or optimizations. Speaking of which, don't be surprised if you have to revisit your configurations to troubleshoot any discrepancies or unexpected behavior. It's all part of the process. Lastly, remember that the configuration is not a one-time process. You'll continuously optimize configurations based on performance evaluations and fine-tune parameters to achieve the desired synchronization accuracy and stability. It's like an artist constantly refining their masterpiece. To summarize, configuring the Synchronization Management Unit for IEEE 1588 and Synchronous Ethernet using the 82P33813NLG chip involves understanding the chip, setting up the development environment, configuring the IEEE 1588 and Synchronous Ethernet settings, accessing and modifying registers through the programming interface, and testing and validating the configured settings. And remember, documentation and troubleshooting are essential components of the process, so take a deep breath and embark on the journey of configuring the SMU. It's not as daunting as you might think.
Thanks for watching. See you in your new video.